right, so today's going to start on the second part of the class. So this is on trig. So trig, a little bit different than what we've been doing in algebra. Nice part is it's kind of like a reset point. So if you're having trouble with some of the algebra stuff, this is brand new. All right, so it's almost like day one of a new class. So first thing I like to do when we start trig is just look at that word, see if there's anything in the word you recognize, like a prefix, suffix, anything at all in there that you may have seen in another word that's math related. Anybody recognize any part of the word trigonometry? Yeah, so specifically the metry part. Yeah. So we see metry in different subjects like geometry, trigonometry. I guess that's it. But you really see metry in those two subjects. And does anybody know what metry means? Or does it kind of look like another word, like at least the first part of it? Meter, all right. And what's a meter?
Like a measure of distance.
Measure of distance, yeah. So metry, it means measurement. Yeah. Metry, so geometry, measurement of geo means earth, so measurement of earth. Trigonometry, well, we got to figure out what the first part means, but metry is something with measurement. How about the first part? Anybody recognize anything there? Yeah? Try, all right. And what does that mean? Three, okay, like tricycle, and things like that. Three is three somethings. And then three of what? Well, the gone tells you what three of something is. What does gone mean?
Like a shape.
What about a shape? Sides, yeah. Gone means sided. Like hexagon, six-sided, pentagon, five-sided, octagon, eight-sided. Well, a trigon, that is another name for a triangle. We normally don't call it a trigon. We call it a triangle. But the idea is we're measuring triangles. That's what trigonometry is, okay? Measuring triangles. So let's look at an example of what that means. A lot of what we do in trig is going to be drawing a sketch and then kind of figuring out where in the sketch do we have a triangle and then figuring something in that triangle out, either an angle or a side. Those are the two things that we have to figure out. So let's start with, again, I'm not going to get into all the details of how you do it. I'm just going to show you where a triangle could come up. Okay. So let's say we have a building over there. We got a person standing there. And we want to figure out the height of the building, okay, or the height of any object that's in front of you. Well, as long as you can measure the distance to the object, like how far away you're standing from it, and the angle to the top of the object, you can figure out how tall it is. It's pretty easy to measure the distance away from the object as long as you can walk to the object. If there's something in the way, like a canyon or a river, that would make it a little harder. But if you could walk to the object, then you can measure how far away you are from it. So let's say you're 200 feet away from an object. The angle, it's a little bit harder to get, but you can get it several different ways. One way is people used protractors before. Well, if you put like a straw on top of a protractor, you almost have like a little barrel on it. And then you can look through that straw and you can aim the protractor at what you're looking at. And if you hang a string from the protractor, it'll always go straight down because of gravity. And as you tilt the protractor, the string will line up with a degree mark on the protractor. So you can kind of make something really simple to measure it, but you can figure that angle out. Let's say it was 30 degrees. That's enough information for me to find the height of that building. And the triangle that I'd be looking at is right there in purple. Specifically, that's a right triangle, right? Because we're assuming the building is perpendicular to the ground. It's built straight. So in that case, we'd be measuring the height of the triangle, which gives us how tall the building is. Okay, here's another example. So let's say we've got something like this. We've got two, I'm going to do an example of this later on in a few weeks. We've got two stations, like Coast Guard stations. One here and one there. And they're on land. And let's say the Coast Guard stations are, I don't know, let's say 100 miles apart. Two Coast Guard stations are 100 miles apart. And there's a boat that calls into the Coast Guard station because they're having trouble. And maybe their GPS doesn't work and it's cloudy, and so they can't figure out where they're at. Can't see any stars, and they can't get their location with their GPS. But they have a light on their boat, and they call the Coast Guard stations, and they say, you know what, we'll flash the light, we'll rotate it, and if you see it, can you tell us where we are? Well, if there's only one Coast Guard station, no, they can't tell the boat where they are. They can tell the boat the direction that they can see the light in, but unless you have a second Coast Guard station, they can't figure out where the boat is. You need at least two. Right? This is called triangulation. So you can triangulate somebody's position as long as two people can see what they're trying to find. Right? So let's say the boat is out there. So we've got our boat, and they turn on their light, and each Coast Guard station can see the light. That Coast Guard station says, all right, I see it in that direction. Again, can't tell how far away it is. They can just maybe see a light blinking. Same with this Coast Guard station. They can see the light as well. So what we've done is we just made a triangle. So the triangle this time is right here. What's a little different about that one? There's no right angle in it. Okay, so that makes it a little more complicated to deal with. But we can still figure out what we need to, as long as we know a couple things, like how far apart the Coast Guard stations are. Right? That should be simple, just because it's like knowing how far apart two cities are. Right? The location of each station is known. They can figure out how far apart they are. And each Coast Guard station can see the light, and they would have to have some kind of compass so they know the direction. Right? And the compass would give them the angle. Right? So you'd have a couple angles, you'd have a distance, and then you could find whatever you needed to get the location of the boat. So that's called triangulation. You can do the exact same thing with a cell phone tower. Right? So if somebody has a cell phone, and that person needs to be located, police can call the cell phone company, get in touch with them, have your phone pinged, and depending on which tower picks it up, the more towers that pick it up, the better, they can locate where you are. Right? Basically, it's something that, like maybe in an emergency, somebody has to find, like if you're hurt or something like that, they can locate your position. Okay, same thing with GPS. GPS is a little different. It's 3D, but different satellites above Earth. As long as multiple satellites can see your position, it can locate you pretty accurately, usually within like 10 feet or so of where you are. And for driving, that's usually accurate enough. Sometimes where they use really accurate GPS is like inside of a room. Like if anyone's ever done anything with like virtual reality, you can wear a device and there's different markers in the room that triangulate your position. So you can kind of walk around the room and interact virtually like in a 3D way by wearing a headset. But it has to know where you are really, really accurately, a lot more accurately than 10 feet. It has to know like to the nearest like inch, where are you in the room? And then you can react with it virtually. But it's all triangulating your position and where you are. So that's a couple different examples of things that we'll do in Trig. Most of this is pretty far away, a couple chapters away. So what we're going to look at today is basically just distance. Okay, if you know 2 points, how do you figure out how far apart they are? And then tomorrow, we're going to start looking at angles. Okay, so we'll focus on what an angle is, how we measure angles. Probably most of you are familiar with degrees. But there is another way you can measure besides degrees, and we'll talk about that for the rest of the week. All right, so let's start with this. Okay, so first of all, the kind of trig that we're doing is, for now, it's 2D. It means everything is going to be done on a flat surface. Okay, so we're not dealing with 3D. We're also not dealing with the kind of trig on the surface of the Earth, right? That would be a little different because the surface of the Earth is spherical, well, mostly, but it's on a curve. Okay, so we're going to be dealing with trig on a flat surface. And the first formula that we're going to look at, out of two today, is the distance formula. Okay, so the distance formula is based on a triangle, and it helps us to get the distance between 2 points. So I'm going to make a sketch, and I'm going to put 2 coordinates in the sketch. I don't know the coordinates. All I know is the 2 points. I'm going to call them point A and B. A has an x and a y value, and B has an x and a y value. Okay, so let's say those 2 points looked something like that. There's A on the bottom, and there's B up and to the right. And the goal is to figure out how far apart those points are. Well, what makes it a little bit hard is they're at an angle. Okay, they're not on a straight horizontal or vertical line. If you had 2 points that are in a straight horizontal or vertical line, and you have a grid behind it, that's very easy to measure. You've got a point here, a point here. Super easy. Okay, you just have to count 1, 2, 3, 4, 5 units. Okay, the problem is if you've got a point here and over here, you can't count units on a diagonal. You can only count units on a horizontal or a vertical. So the goal is going to be to figure out the length of that line segment. Now, I just said you can't really count on a diagonal, but what are the 2 directions you can count units on that are easy? The x, yeah, and x is which way? Horizontal, and then the y is vertical. Okay. So we're gonna turn this line into one side of a shape. And anybody have a guess what shape I'm gonna make out of this? I'm gonna make a triangle out of it. Yep. So we're gonna make a triangle, and the length from A to B is gonna be the longest side in the triangle. So what I'm gonna do is draw it a little nicer. I'm going to draw a vertical, straight down, and I'll draw a horizontal, just like that. And because of the way I drew that, does anybody know what kind of triangle it is? Right. Yeah, it's a right triangle. Now, there's one more coordinate we need to label, this one. We do have enough information in that diagram to label that coordinate because it lines up horizontally with A and it lines up vertically with B. So that should give you a hint at what these 2 values are going to be. Anybody think they can give me the x value of that purple coordinate? Yeah.
x2.
Yep, x2. Because it lines up with this green one right above it, and that green one is at x2. So that's how far to the right the purple one is. Same as same as B. So it's x2. And then how about the y value? y1. Because it lines up with point A, and the y value is how high or low something is. So the purple one is exactly the same as A. So it's y1. Okay. Now that we have that, we can find the length of the bottom side, and we can find the length of, or the height of the triangle. And if we know those two things, we can figure out the distance from A to B. Okay, there's a theorem we can use. If you don't remember it, we'll talk about it in a second. But let's start with how you would get the length of, let's say, this side right here. Okay. Think of that bottom side as being on a number line. Let's say you had a point, this is 0, this is 5. You got a point here and a point here. Make that 4. If you want to find how far apart this point is from that point, okay, without counting, you use subtraction. You subtract these two numbers. The bigger one minus the smaller one. And that tells you how far apart those 2 points are. So in this case, 3 minus 1 tells me they're 2 units apart. All right. So now let's look at this point and the purple point. Anybody have an idea how we would figure out the length from here to there? Yeah, x2 minus x1. This is the bigger value. This is the smaller value. And we're going to subtract them. That's the length of the bottom side. Whatever x2 is minus x1. And that's easy to find because it's horizontal. We could just count that. Let's do the same thing for the height. From here to there. Anybody have an idea how we're going to get the height of that triangle? Yep, it's going to be y2 minus y1. Now, neither one of those is actually what we want. This bottom one is the length of the base. The one on the right is the height. But what we really want is the hypotenuse. Okay, that's what we're trying to get. Does anybody know there's a name of a theorem? If you know 2 of the sides in a right triangle, you can find the third one. Yep, we can use the Pythagorean theorem. All right, and what is the Pythagorean theorem? Now, can you explain what do you mean by a squared plus b squared plus c squared? Is that what you said? A squared plus b squared plus c squared?
It's just the different sides.
Okay. Let's say the formula one more time. Can you just say it one more time for me? Equals c squared. Okay, yeah. A squared plus b squared equals c squared. And Quinn, you said it's the different sides. Like, what do you mean? What's side A?
Well, it can either be up and down or side to side.
Right. It's one of the 2 shorter sides in the triangle.
Yeah, but C is your diagonal.
And C is the diagonal. Yep. And what do you call the diagonal? That's called the hypotenuse. And does anybody know what you call the shorter sides?
Legs.
The legs. Yep. So all we have to do is fill in the length of one of the legs. Well, there's the length of one of the legs, plus the length of the other leg. So there's that. And that will be equal to the hypotenuse squared. So let's fill that in and see what it looks like. So when we fill it in, we've got x2 minus x1. That's going right there. That's x2 minus x1. And we have to square it, because that's part of the Pythagorean theorem. Then there's a plus sign. And then we have y2 minus y1. And that's going in right for b. That's why I have that there. And that's also squared. But then there's one more thing. There's this square root over the whole thing.
Cancels a cube. Does it square?
Right. I'm trying to find the length of the hypotenuse. I'm not trying to find the length of the hypotenuse squared. So what I need to do is I need c by itself. To get the c by itself, you take the square root of both sides, and that gets rid of this. That's why there's a square root over the whole thing. So the distance formula is really just based off of a right triangle. That's all it is. And it's the Pythagorean theorem. So now that we have it, we don't want to have to figure this out by sketching it every time. We just want to remember that formula. All right, let's try an example. So the way it'll work is they'll give you 2 points, and then they'll ask you to find the distance between them. Okay, if you have trouble with the distance formula, my suggestion would be to label each one of these numbers with one of the 4 labels up above, so you know which one goes where. Let's start with the 4. You have 2 choices, because whether you measure the distance from A to B or B to A, it's the same thing. So right now, you've got 2 choices for what the 4 could be. What are the 2 values that the 4 could be right now? Could be x1. Yep, or
X2.
it could be x2. Yeah, it could be either one. Since you said x1 first, I'm going to call it x1. Now that we've labeled that one, there are no other choices. Okay, everything else has to be a certain letter. What does the 5 have to be?
Y1.
It has to be y1 because it goes with x1. The 1s have to go together. And then what about the 3 and the 2?
X2, Y2.
x2, y2. If you label them like that first, then you know exactly where everything needs to go when you plug it in. Okay, so when I write the distance formula, I generally write down the whole formula, put everything that's not a number in it, and then fill the numbers in last. So I do this. Now I've got the whole formula written. I don't have to think about what the formula is. I just have to think about putting the numbers in it. So Holly, what number is going to go before this first minus sign?
The 4.
So what variable goes right there?
The 3.
The 3. Yeah. So the way we labeled it, that's x2, and that's my 3. Jaden, what's going to come after the minus sign?
2.
Okay, what letter comes after it? Look at the formula up above.
X1.
X1. And what's x1 in our problem?
4.
4. Yep. So we've got 3 minus 4. Okay, we're just filling in the numbers in the letters up above. Well, Ruben, what's going to go in the second set of parentheses, my first number?
2.
So we're looking for y2, which is a 2. And my second number?
5.
5. Okay. So now we'll do that out and see what we get. 3 minus 4 gives me how much?
-1.
-1. And 2 minus 5?
-3.
-3. And this is why we could have labeled this x1 or x2, and it wouldn't have mattered, because we're going to square each of these numbers. So if you do end up with a negative, because of the order you chose, the negative is going to go away. That's why it doesn't matter. Okay. And when you square -1, you get how much? 1. And when you square -3? None. Okay, so if they want an exact answer, you're going to write it as square root of 10. Okay, that's the exact answer. If they want a decimal, well, then you'll just use your calculator and type in square root of 10. But generally, if they don't ask for a decimal, I'm not going to do a decimal. Any questions on that first one? And that one's done. You might think, well, yeah, isn't it already done because you circled it? Well, sometimes we get to this step and there is one more thing we need to do. Because the number under that root is a 10, there's nothing more to do. Okay, let's look at example 2. And this time, let's see what happens here. Okay, so here's our 2 points. Let's label them again like we did last time. Serenity, what could I label the 2 as? And you have 2 choices. Yep, I could have done x1 or x2. So we'll call it x1. Kim, what about 6? Yep, that'll be y1. Okay, and the next one is 4. What are we going to label the 4 as? Yeah.
X2.
Yep, that's going to be x2. And lastly, we have the 10. Lucas, what can I label that as?
Y2.
Y2. Okay, take that and let's fill in everything to our formula. So remember, start out with square root. And it's a difference squared plus another difference squared. And no, there is no way to simplify that formula. You have to write it that way. These square and square root don't cancel each other out because of this plus sign right there. Okay, so that's how you got to write it. All right, first set of parentheses. Gianna, what's going to go in these 2 spots? Yep, it's x2 minus x1. And our x2 is a 4, and our x1 is a 2. So 4 minus 2. Quinn, what's going to go in these last 2 spots?
10 minus 6.
Y2 minus y1, which is 10 minus 6. Okay, so let's simplify what we've got there. Madison, what's 4 minus 2?
2.
And then when you square it, 4. And 10 minus 6.
4.
And when you square 4,
16.
16. Okay, so we get square root of 20. And in the last problem, we were done at that step. This time we're not done. The next part isn't trig, it's just reducing a radical. Okay, so I'll talk about how to reduce it. And that's really the most important thing in this whole lesson today, is how do you reduce radicals? Because radicals come up a lot in trig. Does anybody know how you simplify or reduce the square root of 20?
Factor it out.
Okay, so yeah, we have to factor the number 20. And again, I'm going to write this down in a minute. We'll see if we can do it. And you want to factor the number 20 into 2 numbers, something times something. And we want one of those numbers to be something we can take the square root of in our head easily. 5 and 4. Yep. So we just broke up 20 into 4 times 5. 2 times 10 wouldn't be a good way to do it because you can't take the square root of either one of those in your head easily. Once you break that up into 4 times 5, you can separate it into 2 roots like that. You can either have one big root with a product or 2 separate roots with a product. It's the same thing. And now, when you simplify, what's the square root of 4? 2. That's how you write your final answer. 2 square roots of 5. Whenever you reduce, if you're not sure if you did it right, it's very easy to check. Type in the square root of 20. That's what you get. Type in 2 square roots of 5. If you don't get the same thing, then you reduced it incorrectly. But we got the same thing. Let's write down. Okay, if you've got a method that you use to reduce square roots, and it works, and you would have gotten 2 square root of 5 with your method, then just use your method. If you don't know how to reduce a square root, I'm going to show you one method, the one we just did. So the whole key, and Quinn said it right away, was to factor it. And you have to factor it so it's the product of 2 numbers, and one of them has to be in this list. Has to be a perfect square. Okay. Reason it has to be a perfect square is because those are numbers you can take the square root of easily in your head and get a nice answer. So then once you figure out which one of these numbers goes into it, you break your root into 2 roots, like we did right here. And one of them will give you a nice answer, and the other one stays just like it is. And there are other methods besides that method, but that's the one I use. Any questions on that? So I think the first example was to simplify square root of 20, but we already did that. So let's let me make up a different one. Let's do square root of 12. So if you get stuck, my suggestion would be write this list down. You're probably not going to have to go too high. I'd say the highest you probably have to go is 12 times 12, which would be 144. Okay, I went up to 7 times 7. Okay, how can you break up the number 12?
3 and 4.
Yep, break it up into 3 times 4. And then once you figure out how to factor the 12, now break it into 2 roots. Square root of the first number, square root of the second number. And which one of those is going to simplify nicely, the first or the second one? Yeah, what's the square root of the first number? 2. And that's going to be something we do anytime we have a root in trig, the rest of the year. Anytime we have a root. If it can be simplified, we will. Let's try one more of those before we look at our last formula. Square root of 48. Anybody think of 2 numbers that multiply to give me 48, and one of them has to be a perfect square?
4 and 12.
Okay, 4 and 12. So we break it up into 4 and 12. Split that into 2 roots. And what is the square root of 4? 2. But we're not done with that one.
Because we made 12.
Right. We already know square root of 12 is not a problem that is done just by itself. That can be simplified. So if you have to do this twice, then that means we didn't pick the best way to break up 48 to start. Okay? We'll look at a different way to break up 48. But sometimes it's helpful to do it twice because it's easier numbers to work with. Okay? If you do it all in one step, you're going to end up with a bigger number when you start out. Okay, but we'll look at it in a second. And how did square root of 12 split up?
2 square root of 2.
Right. Square root of 12 simplified, I would do it just like this. 2 square root of 3. So now you have 2 times, and we just simplified that to 2 square roots of 3. You can combine 2 times 2 and get 4. That's the fully simplified version of square root 48. Anybody think about another way you can split up 48? It's going to use a bigger number than a 4 and a 12.
6 and 8.
Well, it'll be bigger than both of those numbers. The factor I'm thinking of.
I want to say
16 and 3. Yep. 16 times 3 gives you 48, and 16 is a number in that list. Right here. Break that up into 2 roots. And what is the square root of 16?
4.
4. So if you have to do it more than once, that's fine. I mean, you could end up doing it 2 or 3 times. But if you have to do it 2 or 3 times, there is a way to do it 1 time. This number might be harder to figure out, but there is a number that you could just do 1 time. Any question on that? All right, so that is the distance formula. The last formula we're going to look at is the midpoint formula. So the midpoint formula is a little bit different. It's not telling you how far apart 2 points are. It's telling you where the middle of 2 points is. Okay, so what this is giving you is a location. Right? The answer is another coordinate. And before we even look at it on a diagonal, let's just think about how you would find the middle between 2 points in a straight line. So we had point here and point there. And I want to figure out exactly where the middle is between the two of them. What's the coordinates of that first point?
Two negative two, sorry.
2, negative 2. Yeah. And what's the coordinates at that point? 8, negative 2. Now, in order to find the location of the middle, one of those values, either the x or the y, is pretty much going to be automatic because they're in a straight line. Which value here for the point that's going to be right in the middle is very easy to find because it has to line up horizontally with the other two. Right, this part has to be automatic. Right? It's something with a negative 2. But how would you find out what number is right in the middle? Division? Well, 8 minus 2 would tell us how far apart they are. But I don't think if 8 minus 2 would give you a 6. That would put you like right there. That would be 6. It's not quite in the middle. Yeah?
You add up both coordinates and bottom ones.
Yeah, you add up these two values and then divide by 2. What is that doing? There's a name for that.
Average.
It's the average, yeah. So in order to find the midpoint between 2 points, all it is the average. It's like getting a 70 on a test and a 90 on a test, and you got to find out the number in the middle. You take the 2 that you know, you add them together, and you divide by 2. And you do that when you have it on a diagonal. You do exactly the same thing. You're going to take the x values of this one and this one, add them together and divide by 2. That gives you the middle left and right. Then you take the y value, the other y value, and you average those, and it gives you the middle up and down. So you just have to do the average twice. Right? And that's the midpoint formula. Add the x's up and divide by 2. Add the y's up and divide by 2. When you're doing the midpoint formula, generally you don't have any square roots to worry about. There's no square root in this formula. But a lot of people mix up adding the 2 x's together and subtracting the 2 x's. So don't mix them up. Write the formula down on a piece of paper on your reference sheet, and if you copy what I have on the board, you will have the correct formula. All right, so let's try finding the midpoint between those 2 points. Okay, this will be, I think this will be the last one. Let's start with x1. What's x1 in my formula? Yep, so we can do 3. And what's x2? 7. So we add them together and we divide by 2, because that's how you average 2 numbers. What's y1? 4. Yep, 4. And what's y2? 13. So the worst kind of number you usually end up, if they start you with nice coordinates like that, the worst thing that happens is you end up with a 0.5 when you find the midpoint. Okay, what's 3 plus 7? 10. And then 10 divided by 2? So the midpoint is 5 comma, And then 4 plus 13 gives me how much? 17. So if you want to leave it as a fraction, you could do 17 over 2. Or if you wrote that as a decimal, that's 8.5, 8.5. So any questions on that? So on the test, you'll have 4 of the kind of questions we did today. 2 distance problems and probably 2 midpoint problems. All right. So you've got quite a bit of time. You probably finished that homework. So please use the time to work on that. So it's partially in the book, and there's 4 problems you need to copy from the book. So 15 to 21 and 39 to 43 odd. That's on page 7. Then the 4 square root problems, I just want you to simplify them, just like we did like the square root of 48, square root of 80, and square root of 12. Show me how to break them up, and then show me the final answer. But I'm not looking for any decimals. That's not what I'm looking for.